See, in today's class, we'll speak polarization of electromagnetic wave. See, the name itself indicates polarization. It's something speaks about direction. English meaning of polarization is direction. Even the politician will use polarization, that means to categorize something like that. See, now let us take as usual the wave is traveling in which direction? Yes. That is AK, AH. Let us take AX. This is AZ, A. No. This is your electric field. In which direction electric field is there? Y direction. At this point, this is the amplitude. 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 At this point, this is something. And at this point, this is the amplitude. And at this point, this is the amplitude. Just you can. There is a reason why I am drawing like this. Okay, you can put the arrow marks. Even you can put the direction of H also. For me, H is not needed at present. See, polarization is defined as the direction of electric field. The direction of electric field at a given point. Are you getting? At a given point, as a function of time. Just see. At a given point, let us take. Shall I take this point? At given point, this point, and function of time. See, this is x. X is equal to 0. I assume. X is equal to 0 if I assume. With the time, the wave will change, amplitude will change. See, at this time, what is the amplitude of this? At this time, at some time, this is the amplitude. At this time, what is the amplitude of this? This. If I see like this, at this time it is 0. At this time, this is the amplitude. 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 At this time, what is the amplitude? At this time, this is the amplitude. 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 And it goes on. See what I define. It says the direction of electric field at a given point. I assume that point x is equal to 0. And function of time. With the time, the amplitude is going, keep on changing, and direction remained same. Direction remained same. Are you getting? Means if I see standing the wave like this, the amplitude will keep on changing. If the wave is propagating in this direction, if I see like this, the amplitude keep on changing. This is polarization. What we are going to do. Even you can write H also. H will be horizontal. Is it or this is one. Even for E may be horizontal for this case. There is a possibility. E horizontal भी हो सकता है. E may be Z direction also. Yes or no? There is a possibility E may be in Z direction. Shall I? AX. The wave is propagating in this direction, but what I do, this is your Y direction. This is X. And what about this? Z. But E may be in Z direction. How? This is your AY minus A1 into AZ. This is A, this is AH, this is A. Yes or no? E may exist in Y direction or E may exist in Z direction. There is a possibility. Are you getting? This will be useful further. Direction of E at a given point and function, it is a function of is polarization. Take note of this. Polarization is defined as direction of electric field at a given point. Direction of electric field at a given point as a function of time. As a function of time. Okay? See, I have shown this figure without any mathematical equation. Just at this time, what is that? No, with mathematical equation, I will draw this one. Means not with mathematical, we will get a mathematical equation for this one. Okay? No. The definition is clear? No, let us assume the wave is propagating in X direction. Then direction of this is Ex comma t is equal to Em cos omega t beta x. What is the direction? Ay. Yes or no? This is the electric field is given. Let us assume the wave is propagating in X direction and its electric field is given by this. Yes or no? Okay, no? The electric field is in Y direction or not? Even I said other possibilities there. That is a possible. Then even if you want, you can do H bar also. What is the direction of H bar for this? A. For me, this is important. For me, this is important. No, what I define, it is the direction of electric field at a given point. At a given point. At a given point. Shall I take that point as, that is, at point x is equal to 0. Shall I take that point as x is equal to 0? Shall I take that point as x is equal to 0? You can take any point. I'll take that point as x is equal to 0. No, in this equation, call it as equation number 1 and this has 2. At x is equal to 0, E bar 0 comma t Em cos omega t Ay. Or this you can write it as Ey bar. Because I want to use this notation like this. This is your Ey bar. See what, this much is only Ey. This much is only Ey. Component of Ay is Ey. But I am writing Ey bar. This is equal to Ey bar because it is having magnitude as well as direction. Okay? I'll denote. Then similarly, even you can write this as H 0 comma t Em by magnitude of this cos omega t is z bar. And this can be written as H z bar. But I won't need this. No, see this equation. Is it a function of t? and magnitude is changing with respect to t? Yes or no? Let us see this equation and come to this. At t equal to 0. Take this omega is equal to 2 pi by t. I'll take t equal to 0, t by 2 like this, that is t by 4 or even t by 8 like that. Okay, t by 4, t by 2 and 3t by 4 like this. No, at t equal to 0, what is cos 0? It is this. I have put a sign. Is it up? Better what I do? Just this is a sign. What I have put? It should be like this. Is or no? This is 0. See, at t equal to 0, what is the amplitude? 1 maximum. This is Em. Earlier I have put in the figure in terms of sign, but during electromagnetic wave propagation I say at the end it should be in the form of cos. Make that rectification. Then at t equal to t by 4, the amplitude lesser than Em or not? This is your amplitude. Then amplitude already. Then at t equal to t by 2, what is the amplitude? At t equal to t by 2. Are you sure? T equal to t by 4, check it. Better I'll take t by 8. Like this. At t by 4 0, not t by 2 0. Cos 2 pi by t and t by 4. Cos pi by 2. See. This is at this point is, and similarly at this point, at this time it is negative. Like this. At this time it is negative. At this time it is negative. At this time it is going up. At this time it is going. At this time again 0. At this time again it is a positive. At this time again it is a positive. See what I want to say. This cos omega t, the amplitude keep on changing with the change in the time, but direction remains. This is polarization. At some fixed point, what is that fixed point here? X equal to 0. At x is equal to 0, the direction of E is a polarization. Hence we define polarization is the direction of E at a given point as a function of time. Okay now? This would give the direction of E. Here, if the wave is propagating in S direction, it is polarized in which direction? Y direction. Don't say minus Y or plus Y. It's a Y direction. The wave is polarized in a Y direction. Is it clear? No, the other case I said, if H is in negative something, then in that case, the wave is polarized in Z direction. Is it okay? Then take down. See, this equation is important to me. E bar of 0 comma t is equal to Ey. Ey bar. This is important. Take on types of polarization. Is it clear what I say? Is it clear or not? But I have drawn the sign. It should be a cos. But solution to a linear constant differential equation may be in terms of sign, maybe in terms of cos, maybe in terms of exponential. Nothing wrong, but as per this equation, that figure was wrong. No, this figure is right as per this equation. Shall I have this? Done. Types of polarization. First, linear polarization, circular polarization, elliptical polarization. See, the name itself indicates linear polarization. Linear polarization, circular polarization, elliptical. Means, how will the E direction here? It is along a straight line. E is along a straight line. Here, E traces a circle. Here, E traces a line. Linear polarization means the direction of E is along a straight line as a function of E. Shall we take down first linear polarization? Take down this. The direction of E is along a, the direction of E bar. E bar you want to write or electric field? Anything. The direction of E bar is along a straight line at a given point as a function of time. The direction of E bar is along a straight line at a given point as a function of t. In the same way I define, how I define polarization? Direction of E bar. Here direction of E bar is along a straight line as a, at a given point as a function of time. Is it okay? Then, further this linear polarization is classified into vertical polarization, horizontal polarization, and theta polarization. Linear polarization is classified into vertical polarization, horizontal polarization, theta polarization. Okay. Shall I wrap this? Let us take vertical polarization. No, for a wave traveling in x direction, for a wave traveling in x direction, just we saw, for a wave traveling in x direction, E will be in y direction and H will be in z direction. Okay. Like this. Done. Full stop. If EY bar, it is vertical, direction of E is vertical. If EY bar is present and EZ bar is equal to 0, what is E in Z direction? 0. But I said there is a possibility. To know this, I said there is a possibility that EZ may be Z, E may exist in Z direction also. To avoid this confusion at this point, there is a possibility E may be in Z or Y direction. At present, it is in Y direction. EY is present and EZ is 0. Such polarization we call as vertical. Don't why see sometime what happens? SZ we take it is. It should not be SZ, it should be EZ. Better you write down EZ bar. If EY is present and EZ is 0, such polarization is called vertical. Then take down horizontal polarization. Even Y polarization you can call it as AY polarization or Y polarized. It's a Y polarized. Yes or no? Means Y polarized means the direction is in Y direction. Then horizontal. Horizontal के लिए what is this? EY. Tell me. EY 0 and EZ is present. Then it is called horizontal polarization or Z polarized way. Okay? Then theta polarization. See, if EY bar and EZ bar both are present, then it leads to theta polarization. Shall I write this? No. The total electric field E bar is given by. See, I need to write it is E bar 0, comma. Why? Because polarization is defined at some reference point. That reference point I took x is equal to 3 is equal to EY bar plus both are present here. Earlier only one was present, that's why I took EY bar. But here both are present. Then what is your EY bar? EM1 cos omega t AY. Then what is EZ? EM2 cos omega t is. Okay? Then you can take what is the common in this? Cos omega t. Even I will take EM1 also. Then it is AY plus EM1 EM2 by EM. Is it or not? Then what is your tan theta? What is your tan theta here? Is it tan or theta is equal to tan inverse E by, this will give the direction of theta. This will give the direction of theta. Is it okay this thing? What I wrote? Yes or no? Just I'll write an equation. That figure for this is, see, this both are present, EY and EZ. See, for earlier also you write down the figure for vertical polarization, EY. Write down like this. For vertical polarization. Is it alright? For horizontal polarization, this is in Z direction. It's a two-dimensional. For horizontal polarization, you write down like this figure. This is EZ. For horizontal polarization, only EZ was present. For vertical polarization, only EY is present. No, for theta polarization, both Ey and Ez both are there, but direction is making an angle from theta. Theta depends upon the amplitude of Ey and amplitude of Ez. The direction is something like this. But both are present here. Yes or no? Are you getting? Is it clear? Then next, circular polarization. For vertical, please draw this figure. For horizontal, please draw this figure. For theta, you draw that figure. Shall I have this? No. Take down circular polarization. See, then what is the direction of E here? What is the direction of E? E traces circle. The direction of E is along the circle. Our direction of E is along a circle. Our E traces a circle. Our tip of E is along the circle. Then the type of polarization is circular. In circular polarization, direction of E is along. Note down. In circular polarization, direction of E is along a circle. Next point. In this, again, see, I am assuming the wave is propagating in x direction only. If it is some other direction that E, Z, Y, that will change. Are you getting? Are you getting or not? If it is in wave is propagating in Y direction, then whatever I wrote, E, Y, E, Z, that won't appear. Second point. Everything I am saying, assuming that wave is propagating in x direction. In this, how Ey bar and Ez bar are present. Both are present with the same magnitude, with equal magnitude. In this, one marks question this is. In this, both Ey bar and Ez bar are present with equal magnitude and 90-degree phase difference. With equal magnitude and 90-degree phase difference. Let me check that. Ey bar 0 comma t. What is Ey bar 0 comma t? Em cos omega t Ay bar. Okay. Then Ez bar 0 comma t. The amplitude remains same and magnitude remains same. Cos omega t plus pi by 2 Az. Both differ by 90 degree. Then what is this? What is this? Cos sin omega t Az. Yes or no? Minus or? Cos theta plus pi by 2. Minus or plus? Even if it comes minus also, it won't make difference for our solution. Plus or minus. But whatever you should get, you should put that. Minus or plus? Minus. Then I'll take this as minus. I said difference between them is 90 degree. If I take this as minus, that's why I said it won't make any difference to our solution. See, you should be very confident. मुझे क्या आना चाहिए? What should I get? Is it or not? Then this would be like this. Then shall I have this? See, no, what is totally E 0 comma t is both are present. I said that is Em, I'll take Em cos omega t common ay plus sin omega t divided by cos omega t az. Is it or not? I wrote directly. Is it fine? Yes or no? Then what is your tan theta? R theta equal to tan inverse sin omega t divided by cos omega. This is theta is equal to मुझे ये नहीं, it's okay, theta is equal to omega, it's a linear line. But I am interested in saying the tracing of E circular form. So let us take this as a, I have taken this. For me this is not important. Shall I write this? See, call it as equation number 1 and this as equation number 2. Equation 1, only I take magnitude. If I take magnitude, can I write equation 1 as Ey Em cos omega, only magnitude. And equation 2 is that Em sin omega. Or this can be written as Ey by Em cos omega t, and this can be written as Ez by Em sin omega. Call it as equation number 3 and this as 4. Then square and add. Square and add. Both square. Just what I do. Ey by Em square. This side it is no. Yes, at present cos omega square. I square plus this thing Ez by Em square. This side it is sin square omega. Then what is this? 1. This is your 1. Now tell me, is it a equation of? Shall I write this? This I will write it as Ey square plus Ez square Em square. Whether this is the equation of circle or not. With radius Em. Then I will write the figure something. Shall I write this figure? This one. This is Y and this is Z. It's a 2-dimension. Polarization figure is a 2-dimension. And the magnitude of this is Em. The magnitude of this is also Em. The magnitude of both remains same. And the direction of wave will be like this. What radius of the circle is Em. Okay? This is a circular polarization. Any difficulty you are finding in polarization? Both is simple. Only you need to make x is equal to 0. Get that equation. That's all. Simplify. Then shall go for elliptical polarization in last 5 minutes. I kept everything as it is. First, take on the heading. Elliptical polarization. See, in elliptical polarization, E is along, the direction of E is along ellipse. The direction of E is along ellipse. Take on. In elliptical polarization, the direction of E is along ellipse. Second point. In this both, in this comma, both Ey bar and Ez are present with equal amplitude or unequal amplitude? Unequal amplitude. with 90-degree phase. Hence, shall I write this as EM1, this as EM2? Okay? Then, this is EM1, EM1, EM2, this is EM. Then, squaring, this is EM1, this is EM2, and this is what? Now tell me, is it an equation of ellipse? Is it equation of ellipse or not? That's all. No or yes? Then the figure which I am going to draw is, what is the magnitude of EY? This is EM1. And see, one will be small, one will be large because they are not same. Shall I take this as EM2? Then something, the ellipse will be represented. This is your ellipse with direction. Fine. This completes a polarization, and the problems for this they may ask in the problem. I asked in the 4th unit we discussed find the polarization also. Just after finding E bar, whatever the direction of E bar comes now, that is a polarization. For example, E bar is expressed in terms of AX. The wave is polarized in X direction. It may be plus or minus X direction. If it is EY is expressed in terms of Z direction. EY is expressed in terms of Y polarized. Okay now? Then this completes a polarization. Please turn off the video. Then in next class we'll see the reflection of